Hello, so good morning everyone, and today I will be lecturing about theorems on rectangles. So rectangles. Rectangles are a parallelogram with four right angles. Theorem 1. If a parallelogram has a right angle, then it has four right angles, and the parallelogram is a rectangle. Theorem 2. The diagonals of rectangle are congruent. So diagonal MS is congruent to diagonal KA. So let's try to answer this simple quiz. So given rectangle halo or HALO and A, if HO is equals to 5 centimeters, what is the length of AL? So here, if HO is 5 centimeters, what is AL? So because parallel sides of a rectangle are congruent, side AL is also 5 centimeters. So B. If HL is equals to 10 centimeters, what is the length of AO? So if diagonal HL is 10 centimeters, what is the length of AO? So based on theorem 2 that diagonals of a rectangle are congruent, AO is also 10 centimeters. So C. If AL is equals to 5 centimeters and OL is equals to 12 centimeters, what is the measure of EO? And O. So AL 5 centimeters and EO and OL is 12. What is the measure of no, what is the measure of AO? So to find that, we are going to use the Pythagorean theorem. C squared is equals to A squared plus B squared. So OA, so substitute OA squared equals to OL squared plus AL squared. So AO equals to the square root of OL squared plus AL squared. So why did that become square root? And why did AO lose its squared? That's because to remove, we need to remove AO squared, and this becomes squared root because mo ni ang nanahitabo. Then after that, it becomes AO squared equals to square root of this. So after that, AO squared equals to substitute OL and AL. 12 squared plus 5 squared plus 5 squared. So 12 squared is 144 and 5 squared is 25. So add them together. AO equals to the square root of 169. So AO equals to 13. So this is our AO. AO. So we have another example that includes algebraic equations, the ones that need to solve for x. So given rectangle QRST, if diagonal QS is equals to 5x minus 31 and RT equals to 2x RT, 2x equals to plus 2x plus 11, solve for x. So how do we solve for that? So first, based again on theorem 2, that two diagonals or the diagonals of a rectangle are congruent. So first, QS is congruent to RT. So then we substitute 5x minus 31 is equals to 2x plus 11. And then after that, we group similar numbers. Then when grouping, we will either change or switch. 5x plus minus 2x equals to 31 plus 11. So why? So why did it become to negative and this to positive? That is the rule when switching numbers. So we continue. So 5x minus 2x is 3x, then equals to 31 plus 11 is 42. So now we find the GCF. So since the GCF of 3 is 3, so 3x divided by 3 and 42 divided by 3. So 3x divided by 3 is x, equals to 42 divided by 3 is equals to 12. I know, calculation error. 42 divided by 3 is 14. Yes. So after that, to see that if it really is correct, we can check. So simply, given q as 5x minus 31, so we simply substitute x to 14. So 5 times 14 minus 31. So 5 times 14 is 70. Minus 31 equals to 39. Then RT equals to 2x plus 11. And then again substitute 2 times 14 plus 11. So 2 times 14 is 28 plus 11 is 39. So there you go. They are both congruent. So thank you for listening, and my name is Carl Simon Cispet from 9 Copper, batch 2022 to 2023. So thank you for watching and listening.